In this lesson, we're going to be covering the volume of pyramids and cones. Last time we talked about the volume of prisms and cylinders. In fact, there's a direct, great, beautiful relationship between a prism and a pyramid, and a relationship between a cylinder and a cone. So let's go ahead and get started with our notes. Make sure you have your essential question and your title and all that down. And let's look at a comparison between a prism and a pyramid. So here I have a hexagonal base, hexagonal meaning six-sided, and I am drawing a prism here. And the reason you can tell that it's a prism is because the lateral faces are all quadrilaterals. Big words, a lot of vocabulary here. Quadrilateral meaning a four-sided object. So you can see a bunch of rectangles, basically, that are coming up out of a hexagonal base. That's what makes it a prism. Now if I look at this shape here, I can see that I have a triangle that's appearing, and then another triangle next to that, and then we'll have another triangle next to that, and so on. But if you compare these two objects, what you can notice, and now the drawing, it's hard to represent these things three-dimensionally, but what I see here is I see a hexagonal prism, because remember a prism has two congruent parallel bases. So you can see that the bottom here is a hexagon. I know it's kind of hard to see because you can't see behind what's going on, but the bottom is a hexagon and the top is a hexagon, and they are congruent and parallel to each other, so it's a prism. This over here is a pyramid because the base shape is a hexagon and coming up out of it are a bunch of triangles. So just some terminology here. In the first case, we have two bases. Those are both hexagons. They are parallel and congruent. In the second case, we only have one base. It is also a hexagon, but there's only one of them. In a prism, the lateral faces, or the faces that are coming out of the base, are parallelograms. Parallelograms like a rectangle or something of that nature. But you can see that it's got four sides coming up. This side, this face, it has four sides to it, and it's coming up out of the base hexagon. Whereas in the other case, the pyramid, the lateral faces are triangles. So if you're looking at a shape and you see a bunch of triangles, then chances are it's a pyramid. Now, it says each row is the same as the first. Well, what does that mean? Remember last time we talked about a prism kind of like the idea of stacking pancakes. So when you stack pancakes, if all those pancakes are the same, that means the bottom pancake is going to be the same as the top pancake. See, we're slicing it, slicing it, slicing it. So we're stacking the same thing all the way up. But if I were to stack pancakes on this guy, what we're actually seeing is a pancake on the bottom, and then the next pancake up is a little bit smaller, and the next one up is a little bit smaller, and a little bit smaller, and a little bit smaller till we get to the very top, and the top one is really, really small sized cross section, we'd say. So each row is getting smaller and smaller as we slice it vertically, or slice it horizontally going up. Okay? So that's the difference between a prism and a pyramid. The volume of a pyramid is actually related to the volume of a prism. Now watch this. It's the same relationship as between a cylinder and a cone. So here I'm drawing a cylinder. Remember, a cylinder has two congruent and parallel circular bases, right? So here's a cylinder, and we can see that now. Now, if I take a cone that has the same size base and I put it inside of that cylinder, you're going to get something that looks kind of like this. And I wish I had like a three-dimensional model to show you here. But we get something that looks kind of like this. We have the cone that's sitting inside the cylinder. Now notice that their bases, the circular bases, are exactly the same. The height of these guys is exactly the same. So here's the question. If this cylinder holds however much amount of water, right, because volume is how much space is inside. So if this guy holds a certain amount of water, will the cone fit more or less water in it? Well, we can see that the cone sits inside the cylinder, so the cone itself is going to hold less water. And so here's a picture of just the cone all by itself. I drew the same cone. It has the same circular base and the same height. So you can see that the volume of the cone is actually significantly less than the volume of the cylinder if the circular base is the same and the height is the same, and we can see that that's the case. So here's a question for you. How many cones can actually fit inside the cylinder? In other words, if I were to take a cone and fill it full of water and pour it into the cylinder that's the same dimensions, how many cones is it going to take to fill up the cylinder? Now, some guesses might be, oh, it'll take 2 or it'll take 4. Actually, it works out very, very nicely that it will exactly take 3 cones filled with water to fill up one cylinder that, again, has the same dimensions to it. We can take 3 cones and fill up one cylinder with those 3 cones. Now, if we were in class, I would show you a very detailed explanation. We'd be doing an experiment with this to see how it works. But if you think about the volume of a cylinder or the volume of a prism, remember the volume of a prism is base times height. Well, what would that imply for the volume of the cone? If the volume of the cylinder is base times height, and it takes 3 of these guys to fill this up, what would I do with this to figure this out? Well, let me give you a more concrete example. Let's say the volume of this guy is 60 inches cubed. Well, we know that it takes 3 cones to fill up the 60 inches. So what would the volume be on the cone? The volume on the cone would have to be 20 inches cubed, because three cones that are each 20 inches cubed would make 60 inches cubed when we add them up. So what would I have to do to this volume to get to this one? Well, I'd have to take this volume and divide it by 3. So the volume of the cone is actually the area of the base times the height divided by 3. We rewrite it like this to simplify it a little bit. We say the volume of any pyramid or cone is equal to 1/3 the base shape times the height, the area of the base shape times the height. Go ahead and write that down. That's a very important formula there. So we have the volume of any prism or cylinder as the area of the base times the height. The volume of any pyramid or cone is the same exact thing, except for it's 1/3 of it, because we can fit 3 cones inside the cylinder. Let's go ahead and take a look at a couple examples of this. In the first case, we have a cone, and we're looking for its volume. Well, remember, the volume of a cone is 1/3 base times height. The base shape in this case is a circle, so we have to find the area of the circle. Remember that the area of a circle is pi r squared. In this case, the radius is 11, so we can say pi times 11 squared, which is 121 pi. So what we just found is the area of this circle. Now we need to use the formula for the volume of a cone, which we just wrote down a second ago. The volume of a cone is 1/3 base times height. So we know the base shape has an area of 121 pi. We can put that right here. And the height of this cone is 21. So we can say the volume is going to be 1/3 times 121 pi times 21. And then we can simplify that to 847 pi inches cubed. And then we could, if we wanted to, we can multiply that all out by pi and get a decimal answer. It just depends on how the question is written. For number 2, we have a pyramid. How do I know it's a pyramid? Because we have a base shape, and coming up out of the base shape are a bunch of triangles. And we can see coming up out of the base shape, it's going to a singular point, so it's a pyramid. Okay? Remember, the volume of any pyramid or any cone is 1/3 base times height. So what is the base of this shape? The base is a square. So to find the area of the square, we're going to just say length times width, so it'd be 10 times 10, which is 100. So now we have the base area, that's going to get plugged in right here, and then the height is going to be 26. Remember, the base and the height always have to be perpendicular to each other. So we would get 1/3, 100 times 26. And then simplifying that out, we end up with 86.667, and then this would be inches cubed. All right, moving on to our last problem here. We're looking for the volume of this funky looking shape. Well, this shape is composed of two different solids. You can see that we have a cone on top and a cone on the bottom. So in order to find the volume of the total thing, the whole thing, we're going to have to find the volume of the top cone and then find the volume of the bottom cone and then add those two volumes up. So remember, the volume of a cone is 1/3 area of the base times the height, and the base in this case is a circle. So we're going to find the area of the circle. So the area of the circle is going to be pi times r squared, and in this case the radius is 6, so it's pi times 6 squared, or 36 pi. Then we're going to plug that into our volume formula, so that's our B. Our h for the top cone is 18, so it's going to be 1/3 36 pi times 18. We can simplify that to be 216 pi. For the volume of the bottom cone, notice the bottom cone has the same base shape. It has a circle that's the same circle as the top cone. So we can use that as our base area. Our base area for our bottom cone is still going to be 36 pi, but this time our height is going to be 30 inches, so we just plug that in. The volume of the bottom is 1/3 36 pi times 30. We multiply all that out, we get 360 pi. And then because we want to find the volume of the whole thing, we're going to take the volume of each of the cones and add them up, and we end up with 576 pi, and the units on that would be inches cubed. All right, that wraps up the lesson on pyramids and cones. If you have any questions on this, please make sure you're logging into the Zoom meeting so you can ask me and so you can get help. And I hope that you're doing well, and I will see you again next time.